We know that Kubernetes comes with a lot of great features, like self-healing, like can orchestrate the storage, can make automatic rollouts and rollbacks if it detects that something is not going as expected. It doesn't need our involvement as a human. It can perform service discovery, load balancing, has a lot of greatness in terms of configuration management, and of course, dealing with secrets. However, the Kubernetes platform itself is a great starter in terms of automation. And if we're looking to the story of a microservice, everything happens with our application code, right? Then we go and add a container, and add a Docker file, which is the container blueprint. And then, in order to deploy to Kubernetes, we end up writing Kubernetes objects in YAML format. For some of us, YAML is great. For others, well, we have to use it because this is the way we can operate with Kubernetes. And sometimes we use we write maybe 1 or 2 files, or we end up writing more files as we evolve and have to deploy to other environments, because typically these files contain key values related to how our application is going to operate in that specific environment. We move to another one, we make another set, right? And then we have to ask ourselves, how are we going to manage this on the long term when we need to move across a multitude of environments, when we need to think also about migrations, and we also need to think about how we are going to handle all this complexity for the future of what we're building in terms of distributed system. So for this, because we kind of end up maybe writing a lot of YAML files, or maybe we write only 1 per each environment and it's just scrollable and is a delight to scroll into code, right? So even more with YAML. And in this case, we have to understand our nemesis when dealing with YAML. So most of the time, developers, when they hear about YAML, and myself, maybe in the beginning, I was mesmerized that it's easy to deal with YAML if it's short. But if it's getting longer, it kind of becomes scary, the bigger the YAML file or the amount of YAML files, the scarier they are. So there are some automation heroes for us to help us deal with this complexity. And the first one is Helm. This automation hero is there to help us to extract a little bit the Kubernetes configurations and to manage and update those multiple Kubernetes configurations via the templates. So Helm is coming with the ability to have templates dedicated for our Kubernetes resources, for responsibility of a Kubernetes resource regarding our application. Moreover, it comes with the ability to deploy these many configs as a single application via the concept of release. We look at our application that can have many, config maps or using multiple secrets. We can look at it and say, but this is a single application that I'm looking to it. And even though it has this all complexity under the hood, it's still one thing. So it gives you the unified view of what you are building. And secondly, it gives you the ability to parameterize for multiple environment support. So you are writing templates, but you are not writing many templates or duplicate the templates for the environment. You're just, multiplying the file that contains the values for those templates, which is a much better benefit. And of course, there are some Helm differentiators that are great and that make our lives great. But before going into the Helm differentiators, let's see some Helm action and to see a bit of a demo. So for today, we're going to deploy 3 microservices because, well, maybe it would be better to see something more complex working together than just a simple hello world. So we're going to deploy a ticketing system with the front end and 2 backends feeding the front end. The first front end that I want to deal with is the event front end built with Quarkus. And if I want to deploy this one, I have a few options. Well, but I'm going to go with the Helm chart option and create my own charts first. So first of all, let me go to chart folder and just use the Helm create event to create my charts. But sometimes when I'm duplicating stuff, when I'm realizing that maybe some templates can be reused, I like to use starters. So I'm going to use my starter called event. And this one is kind of boilerplating some stuff for me, but why I use the starter is because it's also coming with a way to validate my values called values.schema.json. So Helm has also this ability to give you, a way to validate what you're doing in terms of values. Maybe you are allowed to use only certain ports for an environment. You should find a way to restrict that thing with a schema. Let's look at what was generated a bit. And if we're looking to what was generated, we can see that we got a templates folder, which of course has templates, and has another set of helpers to define even more templates and more ways of working with those templates. It has some instructions file. It is good to know how we're going to operate with these charts further. It has a test. By the way, this test is very useful for smoke testing. So if you just want to make sure that things are working on the surface for most smoke testing, this is great. And of course, the values.yaml and the values.schema.json, the values where you can put your actual values related to your environment, and the values.schema.json where you're just validating what you put there. So this is pretty much that. Now, if I'm opening my values.yaml, and making a little bit bigger here. So I have hard-coded, not hard-coded, but I have given here my key value pairs regarding my environment. And I can define this and just have them tailored nicely per the scope where they're going to be used. One is for service account, one is for for the deployment itself. Others are related to ingress or to services. So this is quite a great way to aggregate these values in just one place. And by the way, another thing is good to write comments above those to tell your fellow colleagues what is that doing. And looking at this one, what we have here is that you can see that this chart actually needs a database. So I kind of need an extra thing to persist my data in. Luckily, Helm is good with that as well. So with Helm, you get a set of charts called so-called community charts, but also software providers are making their own charts as well. And sometimes they're outsourcing a version to the community or vice versa. To deploy a set of established software, in this case, a PostgreSQL database. So, by the way, don't worry, the slides will be shared and also the how-tos and documented in my GitHub repo. So you can try this on your own as well. And because I'm going to deploy a little bit on OpenShift, I have set a few more extras for my chart. So for my database, I'm just going to use the Bitnami PostgreSQL Helm chart for this one. And I'm just going to shamelessly copy-paste it from here and install my database so that I can further work with it. So that I'm provisioning my database separately, and then I am working with my own chart. Let me clear it and say, now I can install my event and say Helm install simple event. Now you can see here that I said event PostgreSQL because this one is actually the secret that is having all my the password for my PostgreSQL username if I'm using the defaults. So I don't need to hard code the password and just reference it from here. As you can see, it has deployed. The revision is called revision 1. It seems to be working okay. And if I'm looking to my browser, I can see that I have my simple event up and running. Let me close this one. I can see that the event PostgreSQL is running as well. I deployed on an OpenShift cluster, but you can do this on Minikube. I've tried the tutorial also on Minikube, so don't worry. It's working there as well. So that's pretty easy, right? For one microservice. Another way to work with Helm in such situations, when you have you want to deploy something that you depend on, is to deploy 2-in-1 or have the leader chart approach. And we can do that for the landmark microservice, which is again a Quarkus microservice. But for this one, when we're going to persist the data, we're going to deploy the database all together with the microservice itself, just to see how this leader chart approach is going on. So those being said, in my landmark, let's create Helm create leader from the starter leader. So now I'm creating my leader charts. On the leader chart approach, if I'm going to go and see what the leader has, it has is a little bit different from the other type because I don't have the templates folder anymore. Why is that? I'm specifying my everything that I need in the global values.yaml, which can also be validated. But in char.yaml, if I'm going here, I can say what I need for my application to be deployed all together. So I can have dependencies, and I can say here postgresql. Sorry. Here is a version 8.6.4, for example. And here I don't remember exactly the the repository because I don't remember all the names of the links, but it's this one from Bitnami. So pretty much the same chart I used previously. So this way I can say that, hey, you need to install this so that my altogether microservice works well. Okay, we have the dependency, but we need the microservice itself, right? So let's go to charts where I can put my, leader charts. Clear. And in charts, I can put my, my actual microservice. I can say Helm create landmark from the starter landmark. And I created my landmark here, which is pretty much having the same, structure as the previous one, with a difference. But because I'm defining globally my PostgreSQL details, I don't need to define them, all of them, again, at the level of the values.yaml of the chart that is inside there. So in this case, I don't need the secret name. I don't need the server anymore. I just need the secret key to know what to get from there. So those being said, let's deploy this lovely one. Clear Helm install leader. Let me just go a little above. Helm install leader. And then start from leader. So this is going to do the 2-in-1 installation of the things. It's going to take a little while. It's deployed. And yeah, you can see them now deployed all together and preparing to be up and running. And the first one is going to be the leader PostgreSQL. And of course, the landmark is taking some restarts because the database was not yet ready. And now it's going to start as well. So now we saw that we have 2 of these deployed. But let's look at some more differentiators for Helm, what makes it better beyond the templates and the separation of concerns. What makes Helm so great is the fact that it can give you the ability to easily prototype, like you saw earlier. I can easily prototype an application installation. I can separate the non-final values in the values.yaml from the actual objects. I can deploy, those many configurations from the landmark, quite a lot. They were deployed in a single chart instance, so I had 2 charts, two applications, if you want to think about, one stateful, the database, and the other one stateless, the microservice, deployed over there in a single chart instance. And of course, you can check the nested value at every level. That's something I didn't show you, but maybe you can look over in the code. You can have structures and ways to look and to separate and to put to put in your templates in the following way. Like if a value is defined, okay, that part of the template gets enabled. If it's not defined, then you ignore it and just don't have it there. So this is another advice that I have for you. Like if you want to make sure that everything is defined, it's good sometimes to have multiple checks that a value is conforming to your expectation in the template. There are more distinctive Helm aspects. So there are ways to automatically roll deployments via annotations. As you know, when something is changing with, let's say, with a secret or with something else external to your deployment, Kubernetes is not doing automatically a deployment based on that change. It doesn't do that. It doesn't know about that. But with Helm, you can do the automatic roll of deployments using these annotations. Secondly, reusability is encouraged. Of course, we're working with templates. Reusability is encouraged. But it's encouraged not just with the templates, it's also encouraged with the helpers under .tpl and also with the include directive. And it's quite a good way like to have less YAML and less complexity by just using these kind of functions. Besides the automatic role of deployments via annotations, when you uninstall things, you can actually instruct Helm to keep resources on uninstall. So when you're doing Helm uninstall, because earlier I did Helm install, if I'm doing uninstall and I have this resource policy annotation with the helm.ch resource policy keep for my service will be still there upon my uninstallation. So you can do this and protect those resources that you still want to keep. Now, if we're looking to our Helm demo status, we have 2 microservices deployed with each of them having their databases. But if I'm going to scale this, especially the landmark one, so if I'm going to use the part with Helm with the scaling, it's going to be a little bit challenging. How scaling is going to work, especially from the stateful set perspective of the databases. So what happens if you have to, when your system is going a little bit more mature than this? In order to deal with growing complexity, you have to think how you're going to manage everything when you have, again, to multiply this across multiple namespaces. Okay, Helm has made something possible, but the actual databases themselves to be maintained near the microservice is a challenge because, well, the schemas of those evolve as well. The microservice code evolves as well. So you have to think how you're going to deal with stuff that maybe you don't like to deal with regarding regarding databases, like, I don't know, upgrades of the databases, or I don't know, patches, or something that you don't necessarily want to, or backups and restores. Not very fun. So in this case, for this better future, it's great to package this human operational knowledge, like when we used to do backup and restores of databases, which was kind of human operational knowledge. Of course, we were running some scripts, but nowadays we can do this and package this in operators and use operators for this. And the benefits of using operators is the fact that they, besides packaging the human operational knowledge, they work out of the box with kubectl and dashboard. So no more CLIs, extra CLIs to be installed in order to have an operator installed. The resources created by operators are secured by default, and of course, operators can be used even for creating backups or configuring your cluster. So many of those that offer Kubernetes service use operators in order to do those complicated backups or restores of etcd, for example, so that you don't end up doing that manually, because that's kind of troublesome. So what's next for our landscape in terms of making it better for our 2 microservices? Well, you can discover and decide one operator what you want to use on operatorhub.io. That's the place where you can see all the operators that are available and choose to install one from there. Or if you have an operator catalog, use one of those vetted operators from your provider. Then deploy. Follow the deployment instructions. Most of them have deployment instructions. You can isolate and keep the Helm charts for installing the applications, meaning the landmark and the event microservice. They can still be installed via Helm charts because the state is persisted in the database. And of course, you can maintain this postgresql database via the operator. That's the idea, like to have all those cumbersome operations that are related to databases done by the operator. So before creating an operator, let me replace the easiest one regarding the event and go here. And if I want to replace my operator, I already installed one for my application of today. Let me go to the browser. Close this one. Where are you? Yes. Come here. And we're going to remove another one. Let me make this bigger. Okay, so this is my operator to manage my own database via operators. And I actually want to get rid of this one so that my simple Helm chart deployment uses the operator instead of the Helm one that I did earlier. I just need one more thing. I need to look for the service, which I think is, yes, event Postgres. That's connecting for my operator. Just need to replace this one. And to check for my secret, which is one operator related, and it's this one. that is different from the one that I had earlier. Okay, so let me just go here. Okay, and I don't need to uninstall. I can also do Helm upgrade simple from event. And that would be enough to upgrade my Helm chart. Now you can see that I managed all the complexity of installing my event again. Revision got to 2, status is deployed. Let me go to the topology part. And you can see that the application is restarted. I think it's okay. Then I just can go here and say Helm uninstall event, which was the one that I have created initially, since my events doesn't need it anymore. And is like taking the data from the database backed up by an operator. Easy like that. So just upgrade and change, and everything's now managed differently for our database. But we can also create operators. There are different ways. You can use the operator framework, you can use KUDO, you can use kubebuilder, or you can use the Java operator SDK. So if you're a Java developer, like I am, you can go with that one. And this is the demo final view, because we are going to actually look at how an operator was built for the front end for the ticket store service, based on Helm charts, starting with the Helm charts of the ticket store, and go in making the operator for this one and deploy it for this one. This is just for the demo purpose and for the scope of it, because you can maintain the ticket store service easily with Helm charts as well. So it's just for demo. Now, from Helm charts to operators, how this was done, if you want to try it at home, I used the GitHub as my Helm charts repo. So I pretty much packaged my ticket store and indexed it in my GitHub. Just published my charts. These are pretty easy things to do. You generate the index file based on the docs directory, and then I was able to reference the GitHub repo on my local and created and generated the operator and its API based on Helm charts using the operator SDK init command, saying, okay, I'm going to use the plugin for Helm charts. I'm going to use the store ticket store, and you can also use and say which Helm chart version is backing up your operator. In this case, it's 0.1.0, but in my demo, I'm going to use the 0.3.0. So you can actually change these very swiftly and update them very nice. And then you can just apply a sample of your operator and you have everything running. So let's do this for the ticket store and say make install run. And if I'm going to my landmark, no landmark, ticket store. Oh, I hope I haven't forgotten something. No, should be fine. Okay, let's go to the chart part for this one, because I think I forgot something. So go to chart and say Helm create ticket store. -- starter ticket store. Now that I've added also my, where are you? Okay, ticket store here. Let's look at what versions I have. So I can change this one and maybe use 2031 for my version. But if I'm looking to my operator, let's just stop it for a moment. Okay. And go here. So I can have my Helm charts, but also the operator SDK, when it did the init, it did a config and gave the CRD definition. It gave me some default customizations. It gave me some manifest regarding customization, gave me some role-based access control ways of working. So this is the secured part that I was telling you about, and gave me also a sample. So what the sample is doing is actually a CRD that is based on this. It's an instantiation of the CRD that the operator is doing. And in this one, it can have some values that can be easily maintained, and they can be prototyped as the values for what you're giving for your Helm chart installation later on. So that's pretty much it. But let me make sure that I can install my operator successfully. Had a small error earlier. I should be fine now. Okay. Now that I've done this, I can just go and say apply this sample that I showed you earlier and say kubectl apply -f operator, which was config samples and this one to install my ticket store. Okay, and hopefully if everything is working as expected. Hello? Yeah, you're here. I was a little bit worried about it. Yeah, it looks like it's managed by Helm charts, but actually this one is managed by operators. Okay, so you can now see that is connecting and is getting what I deployed earlier in my microservices, like for the events and the landmarks. So let me just go and say for all. It took a little while to aggregate all the data. So these are all the events. The application is working. You can like filter over it. You can just have some small stuff and ordering and all this. So pretty much a ticketing system managed through operator in the case of the UI. Now, some takeaways. So some takeaways regarding the two, just to compare from what I showed you. You can see that Helm has a custom packaging format. But operators can include many more complex configuration data with that package. I mean, you see role-based access control, you see a lot of customizations and CRDs over there. And one important fact is that by default with Helm, CRDs and, the Helm charts for CRDs, for custom resource definitions, are not necessarily something that's supported out of the box with Helm. So you'd have to pretty much do all the heavy stuff yourself. Helm is great for deploying a stateless application, but if you need to maintain something that's stateful, like a database, for example, in a more automatic way, operators are there for you. Then it's great to check your application deployment via Helm, via the release information and all that. But and you can have, of course, annotations that can trigger automatic deployments and many other great stuff with Helm. But you can have you can also find operators useful for operations that are more complex, like backups, restores, and many more. This is where you can find the code. So you can also download the slides because I just shared them. But it'll be published by the GOTO Amsterdam organizers. But you can also get the code from here and try it yourselves and have fun with it. And there are some additional resources. That's why it would be great to download the slides as well. Regarding working with operators, a very great intro done by my colleagues, Jason Dobbys and Joshua Wood, regarding Kubernetes operators. And if you're interested in how Helm operators and other Kubernetes concepts came to life and what was the idea of making them, you can also get the Kubernetes patterns. I pretty much love Kubernetes patterns because it's always looking into those aspects, like what made the Kubernetes folks to actually design this, or others to design a specific Kubernetes resource to be like that. What was the idea behind it? Was it to solve what problem was there to solve? Because all of the Kubernetes resources or OpenShift resources are actually created to solve some problems that us had when deploying our applications, so to help us in making our life a little bit easier. Yeah, that was it from my side. Thank you.